Hello dear students, today we are going to start with the concept of relative velocity. What is relative velocity? We have learnt about the simple velocity. So whenever we are talking about simple velocity, it is actually with respect to an observer who is at rest. So generally relative velocity, simple velocity is also a relative velocity with respect to any of the observer who is at rest. So how we can define relative velocity? Relative velocity of any object A with respect to object B is the rate at which object changes its position with respect to B. So how far or how fast or slow any object is moving away from the observer. So object A with respect to object B, how fast or how slowly it is going away or it is approaching the object B. So that is the relative velocity. So we can say that if any car is going away from another car and another car is also moving, so at what rate the car is going away from second car, or at what rate the first car is approaching the second car, so that rate is called relative velocity of car 1 with respect to car 2. How we can write relative velocity? For example, if VA is the velocity of the object A, VB is the velocity of object B, then velocity of A with respect to B is what? This is VAB. This is VA minus VB. So here B is the observer and A is the object whose velocity we want to find with respect to this B. And if you want to find the velocity of B with respect to A, that would be VBA, VB minus VA. Here A is observing B. And now let us discuss some of the examples. For example, two objects are there, A and B, and if both of them they have the same velocity, the magnitude and directions they are same, then what is the velocity of A with respect to B? That would be VA minus VB, that is 5 minus 5, that is 0 meter per second. We can consider one example. Let us consider two cars are moving parallel to each other with the same velocity. Then obviously the driver of car A is able to see the driver of car B continuously, means the driver of car B is not changing its position with respect to the driver of car A, and same is the case with the driver of A. Or in other words, we can say car A is not changing its position with respect to A or B, and B is not changing its position with respect to A. So, or we can say the distance between the two cars is remaining constant. There is no rate at which the cars are being separated or they are coming closer to each other. So the distance between the two cars would remain constant if they have already some distance and they are moving with the same velocities, or if the distance between the two is 0. And again you see it will remain 0. Both of them, they will keep moving parallel to each other if they are moving with the same velocity. So what we can say, that relative velocity of car 1 with respect to 2 or vice versa is 0 meter per second. Second example, if car A is having velocity 10 meter per second, car B is having velocity 5 meter per second, then velocity of A with respect to B is VA minus VB, that is 10 minus 5 meter per second. Or it is VB A means velocity of B with respect to A, that is 5 minus 10 minus 5 meter per second. Now let us consider two objects are moving. One is moving little bit faster and it is moving with the velocity 10 meter per second. And second object B is moving with less velocity, that is 5 meter per second. If the B is observing A, you can see that in 1 second object A is going away from B by a distance of 5 meter. So we can say that how far the object A is going away from B, that is going 5 meter per second away from the object B. And similarly, if reverse is taken, velocity of B with respect to A, here again magnitude of the velocity means the rate at which both of these two objects are being separated, that is 5 meter per second. But now when you see A is the observer and B is obviously if the faster object is watching the slower object will that will lag behind, it would be left behind, or it will appear that the slower object is moving in the backward direction. So minus sign is appearing here. And similarly, if already the two objects, they are moving opposite to each other, then what we can say that one velocity is 5 meter per second, other is minus 5 meter per second. In that case, velocity of A with respect to B is what? VA minus VB, same formula we are using here, but because of this extra minus sign here, this velocity is 10 meter per second. Or you see, if two objects are coming closer to each other, then obviously they are moving in the opposite directions. Then in what we can say, both of them, if one of the object is observing the second object, the second object must be appearing that it is moving very faster, rather to an observer who is already at rest. Similarly, if object A is observing B, then obviously it would appear that the object B is moving in the opposite direction. For example, a car is moving with velocity 60 km per hour. Then relative velocity of the car with respect to the ground, velocity of car minus velocity of the ground, that is 60 minus 0, because ground is not moving, it is at rest. So we can substitute velocity of ground as 0, and the velocity of car would be same with respect to ground. But you see, sometimes when you are moving and if you are able to see the ground, it appears that the ground is moving backward. So you are the observer who is sitting in the car which is moving with the velocity of 60 km per hour, and it appears that the ground is moving in the backward direction. Then you can find out the velocity of the ground also with respect to the car. So that would be velocity of ground minus velocity of car, that is 0 minus 60. So ground will appear to move in the backward direction with the same velocity with which the car is moving, that is with 60 km per hour. So in the last example, we can replace ground with the trees. When you are moving in a car or bus, the trees appear to be moving in the backward direction with the same velocity. So here also, this is the concept of the relative velocity only. So if you are the observer, it appears that the trees are moving in the backward direction with the velocity with which you are moving in the forward direction. Now, one very interesting numerical you can solve, and you can solve by any of the method, and you will write the answer. You will tell me the answer. A thief broke into a house at 2 a.m. in the night, and at 2:15 a.m. the owner of the house woke up. Immediately the thief ran away towards south direction. Maybe through a window he has gone to the south direction with the speed of 30 km per hour. So that is the speed, obviously very fast speed he is moving in the south direction. So he had started running in the direction of south with the speed of 30 km per hour. The owner came to know about the theft at 2:30 a.m. So after having water, moving here and there, he came to know that something has happened in the home. And when he might have seen the window through which the thief has ran away. So he came to know about the theft at 2:30 a.m. after 15 minutes. So he started chasing the thief at 2:30 a.m. on his scooter with the velocity 50 km per hour. So he came to know that the thief might have gone in the direction of south because the window in that direction was open, and he might have got some clue that the thief has gone in this direction only. So he has started chasing the thief with the velocity of 50 km per hour, and thief already was running with the velocity, and we are going to assume here that the thief will keep running in the same direction with the same velocity, that is 30 km per hour. And this will also be assumed that the owner of the house will keep chasing the thief with the same velocity, that is 50 km per hour, and in the same direction. Now what you have to do, you have to find the time at which the thief will be caught. After how much time you have the velocity of the thief, that is 30 km per hour, and thief has started his journey 15 minutes before the journey of the owner, and after 15 minutes the owner has started moving with the velocity of 50 km per hour in the same direction. Now velocity of the owner is more than the velocity of the thief, so obviously after some time the thief will be caught, and you need to tell me the time at which the thief would be caught. So you can give your answer in the comments, and try to solve it by your method, and in the next lecture I'll tell you how we can do it with the help of the relative velocity. Now let us consider some special cases. If the two objects move with the same velocity, equal velocity, so now let us represent them graphically. We know that the velocities are represented by the slopes of the displacement time graph. So you can see here, if both of the velocities are equal, both of the slopes would be same. So when you are showing both of the velocities by the same slopes, you can see both of these two lines, displacement time graph, that would be parallel for both of the objects. When the two objects move with unequal velocities, so obviously the object having more velocity will have more slope, and the object having lesser velocity will have less slope. So if velocity of A is more than velocity of B, so you can see here A is having more slope than this B is having the slope, and similarly when object A is having lesser velocity and object B is having more velocity, then you can see here object B is having more slope, object A is having less slope. So this is all about today's lecture, and one assignment for you. You can draw the displacement time graph for the two objects which are moving towards each other, means their velocities may be same, they may be unequal, and the condition is they are moving towards each other, means the direction of motion is opposite. So try to draw the graph for representing this situation. So that's all for today's lecture. Thank you.